Hi and welcome to another video. In today's video, we are going to solve a problem from Leetcode, search a 2D matrix. Here, they will give a 2D matrix with the m rows and n columns, and we need to search for a target. If the target is present in the matrix, then we have to return true. If target is not present in the matrix, then we have to return false. Problem statements is really simple. Only thing is we have to do it in O of log m multiplied by n time complexity. So we can use binary search here because array is in the sorted order. If you observe the given matrix, that is 2D array, from left to right, the elements value keeps on increasing, and from top to bottom also, the elements value keep on increasing. So we will follow a similar technique to binary search. We will use the binary search twice here. First is we have to find a suitable row. So in order to find a suitable row, we do binary search once, and once we find a suitable row, that means if our target is within the range of the first and the last element of a particular row, then we can do binary search in that particular row to find that particular target. So this is the approach that we are going to follow. So time complexity will be O of log m plus O of log n, which will turn into O of log mn. So I'm going to explain that thing afterwards also. But just for the introduction, we are going to follow binary search approach with very similar to binary search. Initially, they have given the matrix. We are going to see what is the total rows. Total rows will be len of the matrix. This will give the what are the total number of rows. So if you want to get to know like what are the total columns, then we have to check what is the length of the first row. So this will give the total columns which are present in the matrix. Once we know, first we have to decide on which row our target element is present. For that, we will start with something like so top row will be 0 and bottom row this will be the last row, that is total rows minus 1. So this is the last row. So while we have a valid range for rows, that is our top row should be less than or equal to bottom row. That means we have a valid range. Then we will calculate the mid row. Mid row will be top row plus bottom row divided by 2. So once we get the mid row, then we can check whether our target falls in that range. If matrix of mid row, this is the first element. If our first element is less than or equal to target, let us try to keep target in mind and write these conditions. It will be easier to understand. If our target is greater than the first element and greater than or equal to first element, and our target is less than or equal to last element of that mid row. So that is mid row and last element will be total columns minus 1. So if that means we have found a row and target is present somewhere in that particular row. So we have to once again do a binary search inside that particular row. So here we can declare two more variables to do the binary search, left and right. Initially left will be 0, right will point to the last element of that particular row, that is total calls minus 1. This is similar to binary search. So while our, if we have a valid range, left is less than or equal to right, we have to keep on searching. So first we have to compute the mid. That will be left plus right divided by 2. This is the mid, and we check if our, currently we are at a mid row, if matrix of mid row and mid, if it is equal to target, then we will return true. So what happens if our mid element, that is matrix of mid row and mid, is greater than the target? If it is greater than the target, then every element which is present to the right of it, right, that means mid plus 1, mid plus 2, elements which are present at mid plus 1, mid plus 2 will also be greater than target. So there is no point in searching in that range. So we will bring the right boundary to mid minus 1. So otherwise, we know that our mid is less than the target. If our mid is less than the target, the elements which are present at mid minus 1, mid minus 2 are also will be less than the target. So there is no point in searching for those ranges. So we will bring the left boundary to mid plus 1. Somewhere if we find, if this condition becomes true, we will return true. Otherwise, we got a valid range and we didn't find anything. So that element will not be present anywhere else. So in this case, we will return false. So this is for once we find a particular row. But for this row also, for finding this particular mid row also, we are doing this binary search. In the outer binary search, we have to check whether we have calculated the mid row here. So we have to check our if our target is less than the matrix of mid row of 0, then that means we have to search in the above. So mid row minus 1. So our bottom row will become mid row minus 1. If that is not the case, our top row will become mid row plus 1. So if this condition becomes false and if we don't find anything, at that time we will return false. So I hope this solution makes sense, because initially we will do a binary search to find a suitable row. That means if our target lies somewhere in the range of if a particular row satisfies this condition, this means our target lies in between a particular row from the first element to last element. Then we will do binary search again in that row. So otherwise we will continue finding a suitable row. So this is how the solution is supposed to work. Let us submit the solution and check whether it is passing the initial test cases or not. Yes, as you can see here, the solution is passing the initial test cases. Before submitting the solution, let us discuss the time complexity. So here we are, if there are m rows and n columns, uh, we are doing binary search once for finding the row. So that time complexity will be O of log m, and then for within a particular row we will do binary search to find a particular target. So that will be O of log n. So by logarithmic properties, O of, that is log a plus log b, becomes O of log AB. So instead of, it is not the right way to, this is our time complexity of log mn. Uh, this is our time complexity. As far as space complexity is considered, we are just using some boolean, not boolean, just for storing the total rows and top row, bottom row, and left, right, mid, these kind of variables which are not going to scale anyway with the input. Even if the input size increases to a million elements, we will use the same memory for these extra variables. So our space complexity is O of 1. So we have constant space complexity and logarithmic time complexity. Let us submit the solution and check whether it is passing all the test cases. Yes, as you can see here, this solution is passing all the test cases. I hope you like this video. If you are interested in learning more about data structures and algorithms, you can check out other videos from my channel. Thanks for watching this video.